Section 2, Video 2, all about quadrilaterals. Here we have some examples where we use the definitions of the quadrilaterals that we just learned and apply them to some problems where we're solving for angle measures, side measures, and proving congruency. So example number 1, given this trapezoid, z, y, x, w, and when I initially see that word trapezoid, I think a pair of parallel sides. So I'm going to mark that on my picture right away. And then it says with angle y being 3x plus 19, so angle y is 3x plus 19, so that's this one right here, and then angle x being x plus 1, find the measure of these two angles. Well, I initially see that I could use those two parallel lines to my advantage, and I can almost think of this right side as being a transversal with those two parallel lines, and so I see that I have same side interior angle, which I know that same side interior angles add up to 180 degrees. So I'll go ahead and set up my equation. 3x plus 19, which is angle y, add that to angle x, which is x plus 1. That's all going to equal 180 degrees. Go ahead and do some algebra and combine like terms. For 4x plus 20 equals 180 degrees. 4x equals 160 because I subtract 20 from both sides. Then x equals 40. But I always want to go back and make sure, is that what I'm looking for? And I actually want to find the measure of the two angles, so I need to plug x back into the equations. So I know angle y equals 3 times 40 plus 19. So it'll be 120 plus 19, which is 139. 139 degrees. And then angle x equals 40 plus 1. Angle x equals 41 degrees. Alright, example number 2. The following measurements make this figure a trapezoid. Why or why not? Well, I can kind of draw on what I know from example 1 in that a trapezoid means I have to have a pair of parallel sides, which they've labeled, but it's asking us to prove that. Are they correct in drawing those parallel lines? So they gave me some angle measures here. I'm going to go ahead and fill it in, and then maybe it'll make a little more sense. So angle LMN is 133 degrees. OLN, so OLN, oh, that one's tricky because it's not necessarily, so we really have to look. OLN, it's doing like a, almost like a transversal through there. OLN is 47 degrees. Okay. MNO, so that's this one up here, that's 111 degrees. And NOL, this bottom right one, is 68 degrees. So I initially think, how can I prove that those two lines are parallel? Because that's how I need to show that it's a trapezoid. So I think if I add 111 plus 68, I'm going to get 179, which is not equal to 180. So I don't even really need to mess with that kind of odd 47 degrees because I initially know that these two should have been same side interior, but they're not. So, therefore, not a trapezoid. Because sides are not parallel. Moving on to the next example, it says given WX is parallel to ZY, I'm going to go ahead and label that right away. So WX is parallel to ZY, and WZ is parallel to XY. So I see two pairs of parallel sides. I'm instantly thinking maybe some sort of parallelogram, but I'm not sure, maybe it's a more specific kind of parallelogram. So it asked me to name this figure and solve for all remaining sides and angles. Well, since none of the sides are the same angles, I don't really know, and they're not right angles, it must just be a parallelogram. And a property of parallelograms that we'll talk a little more about in the next section is that their opposite sides are equal. In that, I mean that since zy is 120, I know wx is 120. Because if they were different lengths, then those lines wouldn't be parallel. It's almost like we're thinking that if you draw a line from one parallel line to the other parallel line, they can never get more narrow or more wide because that would make those lines not parallel. So I instantly know wx is 120, and then that wz must also be 250, going with that opposite side. Same kind of thing goes with angle measures. Their opposite sides are equal. So since that upper left is 110, I know this bottom right is also 110. And to find those other two angle measures, I know the sum of those interior angles needs to be 360. You can think about it because if I break this up into two triangles with that blue line there, I can see that both of those triangles add up to 180, and so I have two triangles, so they both need to add up to 360. So if I do 360 minus 110, and then minus another 110, both the other two angles need to add up to 140, and so if I divide 140 by 2, I get 70. So I know that this angle in here has to be 70, and this angle in here also has to be 70. That's a little hard to read, and if I had you doing that on a quiz or a test, I would love for you to write out on the side things like angle z equals 70 degrees, and angle x equals 70 degrees, and so on. But I'll just leave it at that. Example number 4. Given that this is a rhombus, so I asked myself initially, what does that mean if I'm given a rhombus? And I know if I'm given a rhombus, I know it's a parallelogram, and I know that there's 4 equal sides. So I'm going to mark that it's a parallelogram. So we have our parallel lines marked here. Not very well, but you guys know how that works. And then 4 equal sides. So I know that this side is the same length as this side, which is the same length as this side, which is also the same length as that side. I don't want to cover up too much of my picture there, but we know that all 4 sides are equal lengths. So it's asking me to solve for x and then find the remaining angle measures. Well, since I know that all the sides are the same length, I can set up my equation just by setting those two sides equal to each other. So I have 2x plus 9 equals x plus 5. I'm going to go ahead and subtract x from both sides. So I have x plus 9 equals 5. And then subtract 9, so x equals negative 4. Which I initially checked myself, is it okay that I have a negative number? And it is, because that's not a side measure, it's just a variable. And it's fine if a variable is a negative number. So x equals negative 4. And then I could go back and solve for the side measures. But it doesn't ask me to do that, so I'm not going to worry about it. But it does ask me to find the remaining angle measures. So I'm going to clean this up a little bit with my markings. And since we know it's a parallelogram, and I'm not going to mark it because the picture is kind of small, I know that this opposite side is the same. So I know angle F is 35 degrees. And then, like I said before, I know the sum of those interior angles is 360. Because I'm able to slice this into two triangles, and the sum of the angles in one triangle is 180. I have 2 of them, 360 in total. So I know that I have 360 is the total. I know I have 35 and 35 already taken. So, and I know the sum of 35 and 35 is 70. So I'm just going to subtract 70 degrees from it all to get 290 degrees. So that's angle E and G, but I need to do half of that. So I know that angle E, I know half of 290 is 145. So angle E is 145 and angle G is 145. And that's all it asked me to look at. Moving on to the next example. 5, same kind of story. I am given a quadrilateral and it tells me it's a kite. So I think back, what's a kite? And a kite means that you have two pair of consecutive equal sides, which they've already marked for me. So I know those top two sides are the same length and the bottom two sides are the same lengths. And so it's asking me to solve for all those variables. And I do that by setting those sides equal to each other. So if I do the top two, I know 31 equals 2a plus 5. If I subtract 5 from both sides, oh no, it's subtracting 5. Close call. Minus 5. So then I'm adding 5 to both sides, so I get 36 equals 2a. Therefore, a equals 18. This is an a. Alright, I have a figured out. I'm going to do the other two sides, just because I'm working on those. So I have 3z minus 6, and I know that has to be equal to 72, because that's its congruent side. So I distribute, so I have 3z minus 18 equals 72. Add 18 to both sides, so I have 3z equals 90. And then I divide 90 by 3, and I get 30. So z equals 30. Now, angles are tricky for kites because I know that, and this is a property we're going to talk about a little later. So I know it's not quite like a parallelogram, and I know that y is going to be 110, that opposite angle. You can kind of just see, if I like to picture that if I cut this kite in half, right down the middle like that, I know that I can prove that those two triangles are congruent by side, side, side. So you see I have these two outsides and then they share that middle line. And so that's why I'm able to show that these two angles are congruent. And so 110, y must equal 110. But I don't know anything about this whole angle and this whole angle, because those are not, like, each side is congruent, but we don't know about just v against just 2. So I need to look back at how all of the angles need to add up to 360 and then solve for that x. So I know the sum of all of them is 360. I already have 110 taken away, so I'm going to take that away right away. 250. Take another 110 away for the measure of angle u. Take away 65. And that is what I'm left with for angle x, or I guess angle t, variable x. So that one's a little nuanced, and we'll talk a little more about the properties of kites. But if you can begin to think of why I don't know that those two angles are congruent, that's a great start. And so you can kind of say they look a little different. Think about how I can cut that kite in half to be two different triangles. And you'll begin to see, and you need to use the whole quadrilateral interior angle measures always add up to 360. All right, last example. PQRS is a parallelogram, and we need to solve for x and y. So it's a parallelogram. I'm going to go ahead and just label my parallel sides so we remember how that works. And it says solve for x and y. Like we talked about earlier, because lines are parallel, it means they're always going to be the same distance apart, which means those opposite sides have to be equal. So I'm going to go ahead and set them up equal to each other. So y plus 20 equals 3y minus 4. Go ahead and solve like you normally would. I'm just going to subtract y. Leaves me with 2y. Then I'm going to add 4. and I'm going to divide by 2. So y equals 12. Do the same thing for the other side. 2x minus 10 equals x plus 80. I'm going to go ahead and add 10. I'm going to subtract an x. So x equals 90.